Hello everybody and welcome back. Hope you're all feeling well and you're ready to go. We're going to be looking at question number 3 on the 2012 Friar contest. That's the 9th grade level contest. Let's take a look at that question. So, the positive integers are arranged in rows and columns as shown and described below. So we have rows 1, 2, 3, 4. We have A, B, C, D, E, F, G as our column markers. And we have, let's just read the description. The odd-numbered rows list 6 positive integers in order from left to right, beginning in column B. The even-numbered rows list 6 positive integers in order from left to right, from right to left, beginning in column F. All right. Determine the largest integer in row 30. That's our first question, and it's a light bulb. That's okay. So, we can't get down to row 30. That doesn't work. I suppose we could, but we would run out of time because we'd be computing a lot of things. So what patterns can we notice here? Well, row 30 is an even-numbered row. Okay, so its largest number is going to be an A. The 6 numbers in row 30 are going to be listed from right to left in column F. Okay. So the largest number will be, well, it'll be the one in column A, which will be a multiple of 6. So row 1 has the numbers 1 to 6. Row 2 has 7 to 12. Row N has numbers, it goes up to 6n, and it's 6n minus 5, all the way up to 6n. So row 30's largest number will be its multiple of 6, and it'll be specifically 6 times 30. So 180. All right. So we have the largest integer in row 30. Fantastic. B part. Determine the sum of the 6 integers in row 2012. See there, they're using the year of the contest, which comes up every once in a while. It's always a good idea if you know you're going to be writing the contests in, say, 2020, to know some good properties about 2020. Is it a square? Is it a prime? What is its prime factorization? These are good things to know about whatever year you're writing in and whatever contest you're writing in, because it comes up every once in a while. So we've already noted that row N contains the numbers 6n minus 5, 6n minus 4, 6n minus 3, 6n minus 2, 6n minus 1, and 6n. Okay. So if we wanted like a formula to add up the rows, and then we'd be able to plug in 2012, we just need to add up these values, and then we'll have a formula in terms of n for the sum of row n. So, uh, 6n plus 6n minus 1 plus 6n minus 2 plus 6n minus 3 plus 6n minus 4 plus 6n minus 5. Well, that's 6 copies of 6n. So 36n minus 1, 2, 3, 4, 5, so that should be minus 15. Now, we have a bunch of rows already given to us, so let's test this formula. So row 1 is 1 plus 2 plus 3 plus 4 plus 5 plus 6. So that's 21. And 21, is that 36 times 1, because we're in row 1? 36 minus 15? Well, yes, it is. How about row 4? So that's 24 plus 23 plus 22 plus 21 plus 20 plus 19. So that's 129. So if we add 15 to that, we get 144, which, as it turns out, is 4 times 36. So our formula appears to work. So we get a sum of 36 times 2012 minus 15. What is that? 36 times 2012. And then we subtract off 15. That's 72,417. I'll put that in a nice little box by itself. All right. So that's B part, and we already developed a little bit of the theory about this. We know what numbers row n contains. We already know the sum of the numbers of row n. So C part. Determine the row and column in which the integer 5,000 appears. So now we can use our row knowledge to figure out what row it's in, but then we're going to have to figure out what column it's in as well. And that will depend on whether or not the row is even or odd. Whatever row number you're in, that row, its largest number is 6 times n. Alright, so we want 5,000 to be less than or equal to 6n. So let's divide these. We're not going to get an even number, and that's okay, or a clean division. 83 and 1/3 is going to be less than or equal to n. So n is going to be 834. Okay, we want the positive integer that is greater than or equal, the least positive integer that is greater than or equal to 833 and 1/3. And that gives us 834. So 5,000 is in row 834. As an even row, it starts in column F and works its way from right to left. So we know the leftmost one is going to be column A, and that's going to contain our multiple of 6. So row 834, and then we have A, B, C, D, E, F, and G is blank. But we know that we're going to have our multiple of 6, which is 834 times 6. That's 5,004 here. That gives us 5,003, 5,002, 5,001, 5,000, and 4,999, and then blank. So we figured out where our multiple of 6 was, and we worked backwards. We worked from left to right, and we found that 5,000 is in column E. So we're in row 834. And column E. Fantastic. So that gives us C part. How about D? For how many rows is the sum of the 6 integers in the row greater than 10,000 and less than 20,000? Okay. Well, we have a formula for the number of for the sum of row n, so we can just set it between these two values. So what was that formula again? I think it was 36n minus 15. So now we let 10,000 be less than 36n minus 15. So we want the sum of row n to be greater than 10,000, but less than 20,000. That's exactly what the question asked. Before we compute, let's just double check. Greater than 10,000, less than 20,000. We're going to figure out what range of n's does that. We just need to count all those rows up. Okay. So we can bring the 15, we can add 15 to all three of these and not change the relationship. And that means that n is going to lie between 2,015 over 36 and 10,015 over 36. So 278.1944 is going to be less than n. And that's going to be less than 20,015 over 36, which is 555.9722. Okay. Notice that this at least makes a little sense. We already know that there are going to be 5,000s in row 834, so 6 of those is up to 30,000. So we're definitely looking at numbers that are less than row 834, and that's indeed the range we've sort of got. It's not the greatest check, but at least we didn't have something like n has to be more than 1,000, which would obviously be nonsense. Okay. So these are decimals, which means that we can say that n is definitely between 279 and 555. Okay, and we can double check that. What if n is 555? We'll multiply that by 36. Subtract off 15. We're less than 20,000, greater than 10,000. How about 36 times 279 minus 15? Well, we're at 10,029, which is just above 10,000, and certainly less than 20,000. So it's definitely the range we want. So any row n satisfying this range of numbers is going to work, and those are exactly the ones we want. So if we want the number of numbers between two given, like an a and b inclusive, we subtract off the smaller one from the bigger one, and then we add 1. So 555 minus 279 plus 1, that's 277. So 277 of the rows have a sum greater than 10,000, less than 20,000. Okay, and we just double check. That's all we were asked for. How many rows is the sum of the 6 integers in the row greater than 10,000, less than 20,000? Fantastic. So we got that. It's 277. It's rows 279 through to row 555. All right. So that's a nice little question. We didn't make a whole lot of use of the interesting arrangement of the numbers. The columns only entered it into when we were actually trying to pinpoint where the number 5,000 appears. Nonetheless, I would say overall a nice little pattern recognition question. When you're figuring out patterns on these contests, do try not to go overboard proving your pattern is correct. Leave that more for the Galois and especially the Hypatia, because I mean, in grade 9 you're not really supposed to know things like the principles of mathematical induction or things like that would prove your pattern always works. It's useful to know, and you may actually have to apply similar principles on a question, but this was a 4-part question. So at most, any given part is worth 3, and certainly an induction is worth 1 or 2, I would say. So it doesn't leave a lot of room. If they specifically in the question ask you, figure out a general formula for the sum of the rows, then yeah, maybe use a proof by induction or some other technique. But other than that, I would say, state your pattern, state it clearly, and state the general result in the formula, and, just vaguely explain your reasoning. You don't need to use rigorous mathematical proof. I mean, it's the Friar contest. But, yeah, so that was question number 3. And we're almost done the paper. We're going to deal with question number 4 in the next video, so I hope to see you all there.